One, I think we can start now. We still have some people coming in, but I think we can start. I think most people are here already. Um, so yeah, let's get started. This talk is, I don't remember the title. I know it's about NLP. I choose a title that probably is, yeah, something related to NLP, but this will be a talk about NLP and how to use something like PyTorch for building NLP models. That's what we're going to do in this tutorial. So if you're in the wrong tutorial, you're free to leave now. If you're in the right one, let's go. This is the GitHub address. Here you can access all of the resources. We have slides. We have something like this. We have a slide.do, which is a website. You can access it and you can ask questions. Questions that are not so urgent, you can just ask them there. But if you have more urgent questions that you need some clarification or answer, you're free to ask. We have a mic here, so we'll just pass it to you and you can ask. Yeah, and we have a hashtag, please. If you use Twitter, just tweet it and we'll make sure to retweet it later during our break. So just a bit about myself. My origin is Belize, so the Belize is located in Central America. I was doing a PhD for like 6 years. So I did a master's and a PhD in Taiwan, PhD related to data science field, and I focus a lot on NLP. So most of the stuff that I did for these 6 years, this is what I will use to present today. And I gave talks on some of these developer conferences. So I'm a really active speaker at some conferences. And my job is, I do education at Elastic. Elastic is recently went public. It's a company that deals with distributed databases. So I help to basically come up with, help develop curriculums and teach some of the things that the great programmers are doing at the company. And then this is my Twitter account. You can get access to it. And this is my son here. So he's a 3-year-old. And we can see that he's like with the jabiru. Jabiru is a very popular bird in Central America and South America for if you're from that region. And the special thing about the jabiru is that we have it on the, we just recently put it on the coin. So our official coin, official dollar has the bird. And we replaced this bird with the Kill Bill Toucan. The Kill Bill Toucan is a bird that's it's our national bird. So that's cool that the jabiru, although not a very famous bird, but got some recognition. So some housekeeping. We have a survey that we need to fill out from the organizers, and we also have a break-at tree. So initially I didn't have the break-at tree, but we will take the break-at tree. We'll see how we can modify part of the schedule today. So I just want to clarify, usually when I do a presentation, I usually have this slide. I like to put this slide. It's important to know what the tutorial is about and what it's not about. So this tutorial is a very easy guide to understand PyTorch and its concepts. It's a very practical approach to NLP. We're going to focus on the nitty-gritty of applied NLP. And this tutorial will be student-oriented, which means you'll be the focus of this tutorial. We have a lot of exercises, and we have a really packed tutorial for today. And we expect exercises, question session, and group work. So if you have questions that you would like me to ask during the small breaks, please do so in the website I shared before. And this tutorial will be very little theoretical explanation, so I won't focus on that boring part. So mostly will be about application. This is not a deep learning course, very important. We will do some deep learning, but it's not a deep learning course. There's very little use of external libraries, and there's a purpose why I designed the tutorial this way. I think in order for you to get the idea of how to build NLP models, you have to know how to build the components of the model itself from scratch. So that's going to be the focus of the tutorial. And from there on, I believe that once you have this background knowledge and you know how to use a tool like PyTorch, it'll be easy for you to go and see a tutorial and adopt things quickly. So that's kind of the idea behind the tutorial. So more formally, the objectives of the course or of the tutorial is to provide a quick overview of PyTorch high-level APIs. So I'll be using the documentation a lot, especially during the exercise. And it is intentionally built like this so that you have that hands-on practice. And the idea is to introduce the important foundational knowledge to apply modern NLP and to inform students about the latest deep learning techniques for modern NLP. So we will do cover some deep learning stuff, and to engage students and test knowledge acquisition as well, just formally. So just a quick survey. I assume that everyone uses Python here. Is that correct? Maybe raise of hands. Perfect. How about PyTorch? Have you used PyTorch before? Okay, that's great. That's great because the tutorial was designed like this. Like I knew that maybe because PyTorch is a recent tool, so I knew that there's high demand for it, and that's perfect. It is designed this way. How about TensorFlow? Do you have experience with TensorFlow? Yeah, we do have some hands. Yes, that's good. That knowledge will come in handy, and especially when we do form the groups, I would expect that people that have that experience could maybe become group leaders and help out the rest. I do believe that would be a great way to share your knowledge as well. So the journey will be something like this. We have a very brief introduction to NLP. I'm not going to spend too much time on it. I'm just going to say what's the idea behind it. And there's a 5-part tutorial. Feel free to interrupt me if you have any questions, by the way. I'm just talking here, but you can interrupt me if you have questions. So part 1 is introducing the concept of tensors. Most of deep learning and NLP now, and modern NLP, is about tensors and how to manipulate and operate on them. And part 2 will be PyTorch core functionalities, very important part of the presentation. So that's is in charge of background. And then we have part 3, which is NLP basics, and things like preprocessing, tokenization, creating vocabularies, and this kind of thing. And the part 4 is apply deep learning to NLP. So each one of these is a notebook, and I shared some instructions before we started here. Like a week ago, I shared some instructions on how to use something like Google Colab to be able to do all the data science stuff. So hopefully you got that email and you have set up an account and you have access to Google Colab. I hope that that's the case. If not, then you'll have to maybe form groups and just help each other. And the part 5 is best practices for deploying and training NLP models. So this part is optional. This will be more like what you do if you want to do research in NLP. It's like how to properly evaluate models, things like confusion matrices and this kind of thing. Not really important if you only want to apply NLP, but I think it's kind of a critical part of the NLP as well. So that's just the core of the tutorial. So what is NLP? Very brief introduction. My definition is there are so many different definitions, and it's because it's a rarely new field. We have so many definitions. So I just made a very simple definition, which is a computational approach to understanding language, right? Teaching machines how to understand language. So it includes some ubiquitous tasks like the following: tokenization, word sense disambiguation. I will explain more later during the notebooks what these things mean. Name entity recognition, part of speech, you may have heard about these concepts, sentence classification, language generation, question answering, and machine translation. So all of this is included in NLP. And there's like a little Venn diagram here. Maybe not the most accurate Venn diagram, but I think it gets the idea. So NLP, you can see that it's part of the whole AI movement. So traditional NLP and versus modern NLP. So usually traditional NLP is you learn features from data versus human engineering features. So traditional way is just engineering features. And the modern way is to learn features from the data automatically using some tool like RNN, LSTM, or CNN. Right? And each one operates very differently. So we will learn more about these later on. And some of the weaknesses and strengths, well, I only listed 2, but there could be a whole list. So the advantage is that these models, you can learn efficiently from data, learn features. And the disadvantage kind of now is that it requires large-scale data. That's a disadvantage. So me working 6 years in one field, in one topic, I realized that large-scale data was always the problem. I was the bottleneck, especially because I deal with real-world data sets. I could never get access to those large-scale data sets. So using something like CNN or RNN, I always had that difficulty. It's quite challenging. So this is just a high-level overview of what an NLP framework covers. So we have a database over there that can be anything. Anything related to language, of course. Then we have some data preprocessing, data transformation, modeling, and inferencing. So at a high level, this is what it looks like. But each one includes very key components, very detailed components. So we will go through each one at all phases. And that's why I had initially designed 4 segments, 4 notebooks, each covering each one of the components here. So let's just jump into the demonstrations. So some instructions. If you didn't get the link that I shared, I have a folder here with a data set that we're going to use, and you can get access to it now if you have access to the slides. So you can get access to the slide using the following link. I'll just share it here. So this link here, you can use that link and access to the slides, and you can get access to all the notebooks this way. So first thing, slides, then you can get access to all the notebooks if you're using Google Colab, because that's the main thing we're going to use. And if you don't have access to Google Colab, if you have your own environment set up, that's perfect. You can use that as well. But I expect that you would already have installed something like PyTorch and other tools that we're going to use today. So how many of you guys have Google Colab set up? Okay, yeah, a lot, it looks like. How about your own environment? Okay, okay. Okay, so we can just start with the first part. You have any questions before we proceed? Because now the more exciting part of the presentation is going to start, but you'll feel like at times this will go super fast because there's so much thing that I wanted to put into this tutorial, but we only have 3 hours. 3 hours is a very small amount of time, but we will do as much as we could today. And I hope that each one of you get at least something that you can take away with you. That's the main goal. So let me know at the back if you can see the presentation. If you can see the notebook. No? Let's see. I'll try to change it. How about that? It's better? Let's see. I think we can go one level. I think we can do fine with this. So the first part is mostly like covering, it's basically a primer on tensors. I wasn't going to do this part, but I realized that most of you guys are actually starting to use PyTorch or maybe have not used it before. So I think it's a perfect time to introduce it and just get the idea of what kind of features and what kind of tools you have access to with this ecosystem. So this is just a bunch of things that we'll do, like what is a tensor, building tensors. Everything is about tensors at the beginning, but slowly we will transition into the NLP material. But this part is super important, and we only have roughly, I planned 20 minutes, and I do have some exercises at the end. So I will time this just to make sure that we are on schedule with everything. So let's see. So what is a tensor? That's the first question. A tensor is just I would define it as just like a data structure, basically, that you use in deep learning a lot. That's how I would define it, a very simple definition of it. And basically, it's the core data structure that you use to build models and from the beginning to the end. So that's what you're going to do, and you do like transformations on these tensors, and that's just basically what you're doing all the time. So this snippet here is just, you see here, and I will teach you how to use Google Colab, because if you're not familiar with it, it's pretty simple to use. If you have used Jupyter notebooks before, I think you'll be okay. So I basically imported Torch here, which is the main library. Right? If you have access to the notebook, please just follow along. But you will get an opportunity to do this once I cover this part. So building tensors, right, constructing tensors. So the first thing is how to build a scalar. That's kind of the most primitive way of defining a tensor. It's just building a scalar. It's basically like a number or maybe a letter or something like that. It's just one element. So we have one element there. We print it out, and that's it. All right, so after that, we have a 2D tensor, which is a vector, right? If you're familiar with these terms, it's okay, just bear with me. We'll move pretty quickly here. So you'll get a chance to also, if you are not familiar with it, you'll get a chance to explore. Yes? Not really. The way how I designed it is because we don't have a lot of time. So what I will do is I will just go over it pretty quickly, and then I will give you guys some time to just go through the exercises and go on it by yourself. So like I said, most of the tutorial will be, I want it to be student oriented, so you get the hands-on, and you can ask your questions, you can ask me, and I'll be happy to, support. Yeah, you need to create a copy of it. But I'll show you how to do all of this. So just bear with me. I will just go through the tutorial pretty quickly, and then we'll do this all together. Okay, so we have a 2D tensor. We created it. Actually, that's not a 2D tensor, but anyways. Yes. Something happened there. I'll fix that soon. So a 2D tensor will only be, So a 1D tensor is a vector, right? A 2D tensor is a matrix. So we have that there. And then we have a 3D tensor, which is just another dimension added to the data structure, right? And then we can also build a tensor using some other data structure, so using another format. So usually you can build tensors using NumPy, if you're familiar with that. I think most people that do data science are familiar with this tool. So you can also build out of a NumPy array, also build a tensor. So it's pretty flexible and very dynamic in that way. So I have an exercise here. Like I say, I will just give you time to do all of this. And if you have questions, we'll definitely do all of this together. Special tensors. There are some special tensors offered by PyTorch, and the community is very heavily involved with this library. So you'll find that some people use things like a matrix of full zeros. Some would use matrix of full ones. And then you have all these special cases. And once it's popular, then you will see that there's a function for it automatically, and that's pretty neat. And yeah, you have very special tensors like this one, which is a diagonal one. And then we can also build tensors using some random information. Yeah. And you can also build another tensor. So what I mean like that is you build one tensor, it has some properties, you want to preserve that property, and you want to build another tensor with those same properties. And properties, I mean dimension. So when you create it like that. So B copies the properties of A, and you have a matrix full of ones. That's neat. It's so dynamic and so flexible that you can do all of these kind of things. Yeah, the data type is also copied along too. Yes. So we have linspace, which is a function to create like a range. Usually, sometimes we will need a range, especially when we are dealing with batches of data. We will need a range, so we have a function for that. I just recently found out this one. I would usually use NumPy for it, but the library is growing so fast that you always have a new function every time building. So one of the things that you will find out from this tutorial is that you'll be referring to the documentation pretty heavily. That's pretty normal, even for someone that is using PyTorch a lot. You will just reference that tutorial, and the tutorial is pretty cool. It's well built, and it has a lot of examples, which is neat, and you'll definitely learn a lot using the documentation. Even for experts, you always find that you're referring to that tutorial all the time. So we have some exercise here again, just to construct a tensor. I'll give you time for that. Tensor properties, how to check what type of tensor. Someone asked what type. We have what the type of the tensor is. What's the size of the tensor? Sometimes it's really good to probe that before you're going to train a model. And you have tensor slicing, how to capture a specific row, a specific column of the data. That's pretty standard data science stuff here. And we have tensor operations and transformations. So like how to transform, we have like a tensor of ones. How do we convert like the first two rows into zeros and now the rest one? So you can do that pretty easily. And how to transpose, which is a very important functionality in deep learning, how to transpose a matrix. Okay, so we have, okay, here we have, we print out the, so you notice that when we do a tensor here, the tensor, it looks something like that, right? We have the zeros and the ones here. And when we transpose it, you notice that it changes the shape. So not the shape, but you notice the values, they shift, right? So the thing is, when you do the transpose, it's not in place, which means it's not going to be applied to A. Here, because we're using a notebook, the transformation appears, but usually A would not, that would not be preserved. So what I mean by that is, let's say I print A again, it's not preserved. And that's very important, especially when you are like using that functionality a lot. I always remember that it's not in place, and if you want to make it explicit in place, you'd have to use something like this, which is a special character. So in this case, the method will be transpose underscore, and that preserves the transformation. So now you see that it's preserved here, so the transpose of what we wanted is here. So some simple maths, like we have built two tensors, we do a plus here, it's pretty simple, right? If you're familiar with that, this is basically what you do with maybe every deep learning library. And how to add, also if you want to add in place, you use that underscore again. So everything that is in place, you use the underscore, right? So power and sum also, you can have a tensor, you can do lots of different operations on it. You can do power of 2, and then you can sum all the elements, and you have some final output, right? That's a very basic math you can do with those tensors. And you have element-wise multiplication, which is also very important operation in deep learning. So you have that element-wise. You're going to times the I by the ones, and you have that spatial matrix, which is basically just the I itself, back again. So I have some exercise here. It's a very tricky exercise. I would say that if you go through the notebook, if you form groups, if you don't understand some part and you want to like capture what it is, just ask the question. I would say that if you do this exercise on your own, you're in good hands. For a beginner, you will be good using this tool, because it actually will challenge you to think a bit on how you can use those functions. So Cuda Tensors. So this one is a little bit more advanced. So if you're using a lot of GPUs, this is where all these functionalities come into play. So you have some functionalities here, like checking whether a tensor is existing in a GPU or if it exists in the CPU. So you can check all of those, and you have all the different methods to do that. All right, so here I would just, pretty simple to check whether after you have, assigned something to a GPU or a CPU, you want to know later on where is that stored, right? Where are you operating on? What kind of device? So you can actually check like that with this very simple method. So we have like, so you can see that if you use GPU, you know that the difference between CPU and GPU is pretty significant, especially when you are multiplying like really high dimensional tensors. So in this case, for example, I have one here. 1,000 is not so huge, but when you're doing 10,000, for example, that's pretty heavy already on the CPU. So you can see that this is 103 milliseconds. But if you use something like a GPU, and the cool thing about Google Colab is that you already have access to some GPU to play around with. So you will see that the difference here, well, here it took a little while. It's because it has to first connect to the GPU. But if we do it again, It's pretty fast, right? It's like, yeah, it's like two times faster, right? So you can see 20.6 milliseconds. It took a lot shorter time. And you see that the difference between the two operations is that we have the dot CUDA. Dot CUDA means that we want to assign this tensor into the GPU. And you don't really need to know all the GPU stuff, all the low-level stuff. All you need is just that function itself, and then you assign it. And it's so flexible for a programmer that's want to leverage both CPU and GPU and use some form of parallelization. This is so easy. It's pretty easy to use these functions. And that's, yeah. Yeah, yeah. So that's a great question because, so the question was if you can use all the different functions that you have in NumPy, right? And if you can use them in PyTorch as well, or Cuda, you said, right? Yeah. So yeah, so PyTorch is basically built on top of NumPy, so you have access to all the functionalities. And once you have that tensor, you can just assign it to a Cuda. So it's a pretty straightforward library in that sense. So one thing that I do notice from a lot of tutorials is that they teach you how to they have a similar tutorial like this. You may have seen it online. So you have that tutorial where you do element-wise multiplication, you do a transpose, that's good. But one of the fundamental things about this library, and in particular tensors and deep learning, is that you will usually have like a chain of operations. You have to think of data like in a chain of operations. So, and that concept is called computation graphs. So what you do is basically have like a function being applied on top of a data structure, and you keep applying different functions on top of that, and it transforms a tensor, a data structure, into different values, and you keep doing this transformation. So the concept of chaining is super important, but I don't see that it's pretty, like for many people that do tutorials and do like blogs and this kind of thing, they're not focusing on that. I think it's really fundamental to be focused on that and how to leverage it. So I have a basic example here. I think if you can go through this example, you'll definitely understand like how to chain different operations, and you will see that how that makes sense when you're doing deep learning for NLP. Later on, you will see. So I just have some example here that you can go through at your own. We'll give you a chance to do that. These are just more operations, transformations. Yeah, and that's it for this part. So what I would do is basically, I don't know how you prefer. If we can do like groups, I think it would be better if we can do groups. Like just, we can go like just stand up, behind someone, and we can just quickly go through these exercises, just so that everyone gets something from the tutorial itself. So any volunteers for leaders? We need at least, I would say at least 7. Any volunteers? And we just quickly go through the exercise. Is that okay, or how do you prefer we do the exercise? By table? Okay. How much time do you think you need to finish all the exercises? We have like, let's see. Oh, you were working on it already? Yeah, it'd be cool if at least everyone gets to do at least part of the exercise. Anything that you are not comfortable with here, please ask, and we'll go over it together. And I will actually provide I will go over some of the solutions also myself here, so that you can see on the screen. So maybe 5 minutes. 5 minutes. We don't want to spend too much time on this one because we have all the other core material that we need to cover, and we don't have a lot of time. So yeah, let's just start. Please, if you have any questions, just raise your hand and I will come to you. So we'll try. Otherwise, we wouldn't be able to finish today. Um, so I hope everyone got a little bit of like a taste of what PyTorch is about, and you understand some of the the strengths of it. That's basically the idea of the tutorial, just for you to familiarize yourself. You don't need to know everything in this notebook. It's not important. As we dive deeper, you would see that these are just basic operations that you're doing, but you won't need all of this. There are like more important operations that you would have to familiarize yourself with. But just the idea of PyTorch. So let's just move on. Okay, so we have part two, which is what I call like getting started with PyTorch. So the reason why the previous tutorial isn't the starting point in PyTorch, in my opinion, is that PyTorch is usually so the strength of it is not really the tensor operation. The tensor operation is basically what you get from NumPy, what you get from TensorFlow, and all these other libraries. I think one of the strengths of PyTorch initially when it was built was that it has this thing called automatic differentiation, which is just a very complex concept for what we do in deep learning, which is just having a bunch of operations, doing some forward propagation and doing some backward propagation, if you're familiar with those terms, and you will get some output in the end. So that's just basically the idea of the automatic differentiation, which includes the backward process. So here, just to make this concept a lot much easier for someone that's beginning to use PyTorch, what I did is I captured this from a book. I don't remember which book. I'll put the source later on, but I have. So there are a lot of these type of like graph, but I like this one a lot because it actually shows we have a tensor here, a scalar, and you see some transformation being done. It's pretty clean. I like this. I use it for all my presentations, but it shows exactly what is going on at each step, right? So if you understand the basic math, how to do the partial derivatives of a variable, you will see that that's the answer. So what I did was, so in the book you only see this, and they explain what it is, what the concept is, but I would just take it a step forward and actually implement it using PyTorch. So what I did is just implement it here. You have some implementation here if you have access to the notebook. It's a very simple implementation, but it's, how should I say, it's pretty powerful. When you actually implement all these lines of code, you will see exactly what the strength of this tool is, which is all the other stuff, all the the crazy stuff going on behind the neural network is being done automatically behind the scenes. And all you need to do is just just make an explicit line like that, and you should be able to do a lot of different operations behind the scenes. So I can go on and talk about what the strengths are, and what are some of the wonderful parts of PyTorch. But the idea of this tutorial will be just to make it explicit, try to build your own graph, own computation graph, and you get the idea of what it does. And from there, I think you'll be able to extend this into like a neural network and even to a deep learning a model. So I have some example here, and then there's an exercise here in which you compute some derivatives of some variables. Don't pay too much attention to this complicated stuff if you're not pretty familiar with math, and so I think it's pretty easy to understand. Once you go through the code and you code it yourself, you will see what it does. And these figures really help out a lot. So let's see, we have, so each component, right, each important component. So we know that the most important component, as I mentioned, is the computation graph, but every computation graph has to have an input, right? So in this case, it's just a scalar. And you will see that I have some block here talking about what the input is and have some explanation. In your time, you can always go through the brief explanations I put there. And you have an explanation here that says, okay, in order for you to have a sample, you need to have some kind of dimension. And usually in NLP, when you're doing NLP deep learning models, you will have some kind of dimension. So you have a batch size times max sequence length times the vocabulary size. So that's usually what you use. In computer vision, you use something different, right? Some different size. If you use videos, it's a completely different dimensions you're dealing with. So that's just the point of this 2 lines of code here, just to show that you can create some random information of that size, and you can use the properties to get access to it just to see what the size of it is. And you can do some sample also, just with random information. You can reduce it to 100. You don't really need to do the 10,000. So you have that there also. And the point was that in order for you to have some kind of, usually in NLP, what we do is you don't want to work with those dimensions above 10,000. That's going to be crazy. That's going to be too intensive for your CPU if you only have a CPU. So what you usually do is we want to reduce that to something like 100. So with that idea and that need came these things called word embeddings. So now we're not really dealing with that 10,000 dimension. Now we deal something like 100 dimensions. So if you have heard about word embeddings, that's the whole idea behind it, just to have something more efficient to work with. I explained it there in some paragraphs. And I just gave some exercise here on how to, the kind of things that you need. You need to use something like permute. Sometimes you need to change, instead of, usually some models would want or require a certain dimension. So usually sometimes they would have something like sequence length at the beginning and then batch size. So we need to like transform the tensor itself. So I would use something like permute, but there are other functions you can use as well. So that's just a method. And then, so we have the computation graph, we have the input, then there's something called linear transformation. So what is that? Linear transformation is just, I think we saw a bit of it here. No, actually not. That's a very simple figure. So linear transformation is something like this. So there's some math here. It's a weight times the input plus bias. So that's kind of the basic component of a neural network. And how do we put this math into code? So you can imagine there's a lot of things that you need to know, but basically what we're doing is we just need some input, and I have the input here already. I just specify my input, and then I have some transformation that I want to do, right? So I have my input and I want to transform it for it to give some y value. And the wx plus b is actually encapsulated in this object here. So all you need to do is just pass in your dimensions, and all of that is taken care of for. By the way, when you do something like this, what you do is you have to initialize. If you're familiar with neural networks, you have to initialize your weights, you have to initialize your bias, and then you have to do the transformation later on. But with these objects here, with these classes, you already have those things going on behind the scenes, so you don't need to explicitly do it. All you need to do, or you'll find out, all you need to do is you just need to specify the dimensions, because it's the same transformation you need to do anyways, so you don't need to explicitly say that. So you have an output here. And then there's nonlinear transformation, which is what's called the activation functions. So after you have some linear transformation, you want to apply some nonlinear transformation on that output. And so you have a different function for that. Usually we use sigmoids, we can use tanh, ReLU, all those concepts in neural networks. I'm not really going to go deep into those concepts. I think you can read about them later on. It's not so important in this tutorial. Okay, so any questions so far? Anything that you would not, yeah?
You used the variable FC. You probably mean fully connected?
Yes, yes. So yeah, so the idea is just that it's a fully connected layer, and you would achieve that just using that line of code.
What is the broadcasting lag? So what are the dimensions of the connected layer, and how does it map to the tensor?
I didn't get that question, sorry.
How does it map the dimension of the fully connected layer to the sample X?
How does it match the dimension of the...
So where's the input?
Oh yeah, so usually what you do is, that's something, so I struggled with this when I was initially learning PyTorch. That's one of the things that I think was lacking at the beginning. You didn't know which dimension you needed to put first, or what dimension goes second, and so forth. So usually what you do is, since it's a chain of operations, usually what you do is you put the dimension. If you don't know which size to put, you would put the last dimension coming in. That would be the first here for the fully connected layer. So when you're designing neural networks, that's something that you need to keep, you need to be aware of, that if you put a different size there, it will be incompatible, and usually it throws an error. So, yes. So it's already encapsulated using this one, using the linear object here. It's already packaged. But if you wanted to do it explicitly, then you would have to do it on your own, like create your weights.
Well, I guess what I'm getting at is you're doing wx plus b,
Yeah.
and you're specifying the x by putting in sample x to the call there.
Hmm.
Where are you putting in b?
Yeah, that's what I tried to explain. That it's already done behind the scenes for you. It already knows which dimension, what's the size of it, and it just uses some initialization already for you.
Oh, I guess that's the
Yeah,
question. Is
yeah.
What values does it
What values it chooses? It's a good question, and you can see in the documentation that it has all the different choices. You can change.
So there's
Yeah,
some default that
yeah, it's a default. Yeah.
Quick question, do you need to run a session for that, just like TensorFlow?
No, you don't.
You don't?
Yeah, this is like I forgot to mention, but everything is just eager execution. So
Figure execution.
yeah, everything is done automatically. Yes. Hmm.
Sorry, can you go through the linear transformation again? Can you walk through what exactly that code is doing?
Sure.
The time period.
Sure. So we have an input, right, of that size, and
An input of what size?
so we have 64 by 60 by 100,
Okay.
right?
So like this is a rank 3 tensor, right? So it's a 3 by 3.
Yes. Yes. It's hard to picture, but you can just imagine this is it has a lot of dimensions here.
Like a cube, it's a lot.
Yes. Yes. Okay. And let's say you wanted to build a neural network, a very simple neural network that only has one layer, one fully connected layer. Usually what you do is, basically that is what is represented up here in the equation. And what you do is you have to explicitly define what the weights are, what the biases are, and all of that. But what I was saying is that once you have this line of code here, this linear, and you specify the dimensions of it, you have already everything done behind the scenes. But the most important part, as someone, sorry, I did. So it's just like, as I said, it's just like it's just a transformation on X, right? That we're doing, but we're just applying weights and biases, right? Yeah. Yes. Yes. So 50 would be the size of the layer, the number of units. So like I don't have a figure here, but it's if you know neural networks, you when you have some input, you would have some some layer, fully connected layer, but you have to specify a dimension for it. It could be 1, it could be 2, it could be how many neurons do you want? Basically, that's the question. And in this case, we just choose 50. It can be any.
Can you just print this, sample underscore x?
Oh, you want to?
Yeah, I want to see.
Okay. We had it at the beginning actually. Let's see. Yeah, we can do that. That's no problem. Right. So we want x. Let's see.
So x is going to be, it's just going to be random numbers with a shape of, is it 64 by 60 by 100, right?
Yes, just random information. It's just for illustration purposes. It's not really anything important about special about it.
But the fully connected layer is going to take 100 dimensions and then reduce it down into 50, right? So the output of that transformation is going to be another tensor of 64 by 64 by 50, right?
Yes, that was a that was a sign.
That's what was not clear. Thank you.
Yeah, that was a exact transformation. Mm-hmm.
And my question is, I looked in the documentation, so linear
Yes.
where it's true or false, and it sets it a particular way depending on that.
Yes, exactly. Yeah. Mhm. Yeah, and I printed out the sample. It looks, right, it's crazy. It is random information, yeah. I just wanted to have an example here. Mhm. I'm sorry, I'm trying to go a little bit faster because, like I say, this is just PyTorch stuff. We're not even touching the NLP stuff yet. So, because of time, I need to move. All right, so other component is Softmax Classifier, another type of transformation here. Right? It's just, I have an explanation here. It's just a normalized representation of the output. The output would be basically what I'm outputting from the linear transformation, right? So just another transformation, you apply some function again, and you keep doing this, right? So you can see that it's just a chain of operations that you're doing, and you're just calling a function, and everything is just being done behind the scenes. And if you ever need to change what softmax do, you can actually change that behavior of the softmax function. So yeah, that's basically what it does. And the softmax, of course, is just a distribution, right? The range 0 to 1. So you see how the values are from 0 to 1. So, and then I have some exercise here just to get some more practice on how to chain those linear layers and non-linear layers also. You can practice that. So I think it's a good time to try to go over the notebook. I didn't go over this part so much. I think this one is very important in this notebook. Um, Let me just take like 2 minutes to explain it. So we have two tensors, right? We have two tensors, and I want to do some forward transformation, some forward transformations. So what I do is just define layer one, and I have two tensors, and I say, okay, I want to require gradient equal true, which means I want to apply some kind of some gradients transformation on that. So I say true. If this was false, I cannot really obtain that those values from this, and you have to explicitly say it. So and then layer two is so again it's visually more clear here on the figure, and that's why I didn't want to go over it because I think it would take a little while to go over each part.
What do you mean by gradient?
So gradient is just like some values that you get from an equation. So the equation just specified here. Mm-hmm. Yeah, so let's try to do the exercises. I think that's a better choice here. Just to get you more familiar with how to do more tensor transformations. And I think the other exercise was on how to chain linear layers. So try to combine like 5 linear layers. Just use different dimensions just to get some practice. You saw that I just used one, but try to chain some of them just to get the idea on how you would chain all these operations. So just try that for now and maybe 5 minutes or so. Always, if you have questions, just let me know and I will come to you. I know this is going pretty fast, but I have to keep up the pace because we have a lot more content to cover. Sorry, I'm just going to. Okay, so I'm gonna move on. So I'm gonna move on. Sorry. So these two notebooks, basically, I just want to say that in your time you can go through them, try to understand them. I have like long descriptions. You can go through them. If you need any more information, you can always search for the terminologies that I included there. It make it much easier for you to understand. I would say that if you want to do like the rest of the notebooks that I have here, it'd be really important to go through those two notebooks. I don't want to really emphasize too much or put too much time into it because I believe that you can do this on your own. I truly believe that. I think the more unique part and the more important part of this tutorial will be the other segments that we will cover. And you will see that we're not going to do all the tensor stuff anymore. You will see that everything is just like very high level. So let's just continue so that we make it for the break, because we have a break at 3 o'clock. So let's go. And for this, I will take my time. I will explain parts more in depth. It won't be so fast like the first two tutorials. So in NLP, we have different kind of tasks that we can work on. These tutorials that I prepared here are more specific to classification, because classification is something that's much easier to explain. If you have something like language generation, that would definitely be something more advanced. But I think classification is something you can use to easily explain concepts. So the first thing that we want to do is load a data set, right? In that folder I shared, there's a data set that I used. Actually, that data set is part of my, I wasn't supposed to make it public, but I made it public for this tutorial. I think it's really nice to have like a real world data set. The only thing I would say is that don't try to make it public. Just try to use it for your own purposes and you know, educational purposes. That's the only thing I ask. So we have a data set. So here is just some functions. I can just, we have some utility functions that I declared here. Not so important. But when you're doing like Google Colab, how do you connect with your data? So you have a data stored in a Google Drive, right? How do you get access to it? This is not your local machine. So what you do is you have these two lines of code here, if you have the notebook in front of you, and if you try to run those two cells, you would see that there's a message here with some URL here. So basically it's asking for authorization to get access to Google Drive. Obviously this one, you cannot access my Google Drive. If this was the case, then you know that would be really bad. But yeah, the cool thing is you can make a copy of it, and then you can access your own Google Drive. So if you try it, so it asks you for signing. If you sign in with your Google account, you give it access. It's perfectly safe, by the way. It's your account, so you should be fine. So then you paste that code, and basically what I'm doing is just mounting the drive, like you would mount, you know, your local drives. So now it says it has mounted the drive. This is very important because most of the time you will need a data set anyways. You won't want to work with like random information. So this part is very important for Colab. So you have the data, the drive mounted. And my data is stored in the folder in my Google Drive. So it's like merge training. That it's a pickle file. It's already stored there. And you have access to that already in your Google Drive. If you made a copy of it, you should have a copy of it. If you don't worry. We will have enough time to make a copy of it and go through all the different steps. So I will load the data. And notice that for those people that are familiar with pandas, it's basically a data frame that I'm using here. One thing I found when I do like a lot of research, I would always want to use a data frame. Every time I would use a data frame because it has like those nice functionalities to, you know, render a plot or something like that. I wouldn't initially just go jump straight into working with a tensor. I want to know more about my data, so usually I would store it in that kind of format. And so you have access to that one in the data frame. And yeah, I just plot here the distribution of the dataset classes. So it's an emotion labeled data set. So you have 6 emotions here. And it's not the entire data set because my real data set has more emotions than that. more emotion classes, but just for this tutorial case, I just use this 6 emotions. You can see also the distribution here, how many records are for each class. It's a pretty huge data set when you think about it, compared to what you have access to. So it's a bunch of tweets, basically what you get. It's just some tweets already pre-processed for you. So you have it something like that. There's a, right, data.head, render 10 samples. So you can see the 10 samples here. We have text, and we have the emotion class, right? And it's not so important how I got those emotion class. If you really want to know, I have like a paper for it, and all those details are there. But it's just important that it's just the emotion of that text, right? And then there's some pre-processing that you need to do. You have it very nice in a very nice format. It's already shuffled and everything for you. You want to do some pre-processing, but you notice that the text is already very clean, right? Usually tweets don't come like that. So I already did a lot of the heavy work, right? If you want access to that, all of that, the real data set, and you want to know how to do like this kind of pre-processing, I also have a notebook for that. But I thought it would be so time-consuming. So all that information, I would definitely share it. I have like an extended thing that I will do, and I will share everything on the slides. Yes. You're welcome. So after the pre-processing, which there's no pre-processing here, we have tokenizing and sampling, right? These are two very important parts of the transformations that you're going to do to your data set. And the tokenizing part is basically splitting your text into the word components, right? So that's basically the idea of tokenizing. And sampling is just sampling that data set all over again. So in this case, because this is a huge data set, and I say that after 10,000, you will see that you will start to face some challenges with the computation part. So what I do is just sample 50,000. I don't want the entire data set. And in fact, if I try 100,000, I think the notebook will break. So but you're free to play around with the entire data set and find ways to make it run. I'll be happy if you can do that. But I didn't get to do it, so. Okay, so we have a sample, and we have like the tokens. So let me just print out what I mean by tokens. So let's see. Right, so you can see that it's the token size, right? Not really the token itself. I didn't store the token itself. I think, yeah, it didn't store. So you only have the token size, which is the number of words in each sentence, right? But why do I want that information? So that information is very important when you're doing like batches. You want to put the batches in terms of the token size together. So that's something that you would want to do. So it's, like I say, it's just part of the pre-processing step. Sorry? So usually depending on what kind of task you're working on, for this classification task, it's not so important. You can actually just do it random. But because I had designed this notebook for machine translation, I had to do something like this and get that information so that I can put batches together that of similar size, because that's usually very good for machine translation. But for this one, we won't use that information. I just had it here just to show. Sometimes you will need this information depending on the task you're working on. So we have now I think this is very important. So we want to construct a vocabulary out of our data set. We have all our text here, very nicely formatted, and we want to create or construct a vocabulary and some indexing. Why is that important? Because the next step would be to establish features. What kind of features are we going to feed into the model? And usually what we do is in NLP, usually we use word embeddings. That's the first thing that we're going to use. That's like a very typical use case. Use word embeddings. So we need to construct a vocabulary first before we even talk about embeddings. We just need to construct a vocabulary because we need to tell like the model what we want to embed, what kind of words do we need to get those embeddings for. So that's just basically the vocabulary. And this class does that. I don't want to go over the details in what this class does. You can basically tell what it does, but it's just rendering the vocabulary itself. So after I do, let's see, just run it. Right. So just some strange word here. I hope that doesn't break the code. I never saw it before. But anyways, so you can see. Yes. Yeah, you're right. And usually that kind of words, as a best practice, usually you would have to normalize that kind of word, right? You remove the A's, remove all the repetitive R's. But it just so happens that in this case, I missed that one. Something happened. It happens. Okay. So hopefully nothing breaks later on. Okay, so after you have that vocabulary, you would use that information, right? You have that information accessible to transform your data. So now you have all the words that you need, and you need to convert each sentence into a tensor. How do we do that? How do we convert each sentence into a tensor? A tensor of values. And each value in that tensor would be basically ID, an index into that vocabulary. So what I mean by that, so let's see. So we have two sentences. I select two sentences, and notice that when I print it out, some weird numbers show up, right? So we're not dealing with text anymore. We're dealing with numbers, right? We have done all the transformation already. So this is a sentence. No one can say what that sentence is. No one. I can bet on that. No one can. But right, you can see that it's an ID, a word ID, an ID into that vocabulary, and each ID represents a word in that vocabulary, right? So far, so good? Okay. So after that, let's say we want, so there's some exercise here. You can try it on your own. We'll do that after I finish out the notebook, or you can try it. So after that, we have to do some padding. Notice that some sentences are longer, because you can see the first one is a lot longer than the other one. It's longer. You see the size, right? So what you do in that case is you need to pad it, because if you want to do something like a standard neural network or a deep learning model, you have to have those data the same size, the inputs at least. And that's very important when you're dealing with models like RNN. You'd have to have that already normalized already, the same size, each input. So that's basically the concept of padding. And I do a padding. First, what I want to find out, what's the max length of all the sentences, just collect the size of all the sentences and check what the max length of the longest sentence is. And in my data set, it's 69, so we have a tweet of 69 words. At the beginning, when I saw that 69, I thought that was wrong, but after Twitter changed their policies, now you have longer text. So you have some words, some sentences with 69 words. So now you have some padding that you need to do. So this function takes care of that. So let's see. Okay. So what I did here is I padded the inputs. So now you have all of the same size. All the inputs of the same size now, right? And you can see the padding was done just using zeros, right? So that's standard, right? Your data is standardized now using the padding. I know it's hard to understand what it means, but just think of it that it's just a sentence, right? So after that, we have a binarization step. And this one is going to take care of, so we took care of our sentences, our input. Now we have our target classes that we need to take care of, right? We cannot train a model if we don't have classes in this case, because this is like supervised learning, so we need classes. So all this code takes care of, so this is like scikit-learn. If you're familiar with scikit-learn, I hope you are. So scikit-learn is just have a lot of utility functions that you can use to just transform your data, do some kind of special operations in your data, and you get a lot of functions there. So what I did there is just to obtain my target values. So my target looks something like this. Again, we're dealing with numbers. We're not dealing with, everything is numerical values. So now it's something like this. The classes are like this. So for example, let's say this was anger, and this was, I don't know, disgust maybe. I don't remember really the label number, but each one is a different class, right? Because it's a one-hot encoding. And these are just two records with two different classes. Right, so our data looks like this again, just to refresh. I have a text, emotion, and a token size. That's the pandas data frame. And now we want to, so as I said at the beginning, what was the, I didn't know what was the emotion class here. So I just created like a function here just to get access to what was the emotion label, just to keep track of it. These are just like things that you do to just keep checking that you're in the right direction. Not so important for this tutorial, but it's just something that you need to keep track of. And I have some more additional code that I use to just to run more checks that I'm in the right direction. So you can see here that I'm looking at the first sentence just to make sure. Yeah, I'm there, the same sentence. So after binarization, we have the input represented in numerical values. We have the target represented in numerical values as well. What do we do next is we need to establish batches in order for us to do a training. So these are more functions that I use here. So you can see that I'm using this train test split function that's provided by scikit-learn, another very helpful function. And that just splits the data into a training, test, and validation data set. So we have three portions, right? And each one has a different intention. So the training data set is for training the model. Testing data set is for basically testing the model on the go while we train. And the validation is a hello data set just to check whether the model really generalized well, or it's doing well in the prediction. So that code takes care of that. Let's see again, just to make sure. And it's divided like this. So remember it was 50,000 records. So our training data set is 40,000. Our validation 5,000, and our test 5,000. Why do you see a bunch of numbers? Because I actually printed out together with the tensor the target and the input. So you saw that those are just pairs, right? So now I think this is the core thing. The thing that I really like about PyTorch is that initially it was built with these very nice classes. So usually when we work with training data sets and validation data sets, we have the data set in a really nice format. But you will notice that even if you have your data split and everything, you still need to do extra steps on that data. A lot of things that you need to do to get it right in the right format before you feed it into a model. And PyTorch provides very good support for that. There are a lot of nice classes that you can use to take care of a lot of the things that you need to do with the data. So I will just show what I mean by that here. So I just have some parameters here, like the batch size, which is 64. And then there is the different sizes of the trained, validation, and the testing data set. And then I would import those classes that I want access to. So why do I want to do all of, you have my data in batches already. But I don't have them in batches. I have them training, validation, and testing. No batches yet. how do I make sure that I have my batches and that this is done very efficiently? How do I do that? Usually what I would do is, before what I did is use NumPy. I would just manually do it, manually do my batches, and then I would feed in the model. But what I realized is that I did a lot of mistakes while doing this. Usually I would have some error. Usually I don't know if you have faced this before, but sometimes I would even feed the same batch again to the model, and this would create a lot of problems during training. So there are some efficient classes provided by PyTorch to take care of all of that. So one of them is a dataset class. So what I did here was just provide like a class that specifies how I want to set up my data. So here I have this very nice class that I specifying how do I initialize it. I want it, the self.data, to have the input, then I want that to be the target, and then I want the length of it. I want that information. So this is going to encapsulate all the information that you want to use during training time. And when you specify the get that item function, what do you want to get from it? So you want to get something that's like in a tuple, right? You want it to be the input, the output, and the length of the text. So just like the data frame I showed, that's the same thing that you're seeing here, but now we're using just tensors. We're not using the actual real text, right? So just imagine it that way. And I can establish more functions, and I can create various kinds of functions, and everything is all taken care of here. So let's say this is a very simple class that I built with the dataset module, and I would just try it here and see what it does. And that's the best way of showing, right? So let's see, I forgot to. Let's see what this class does. So we have it here, and we provide the input tensor train. We have a target, well, we have the pairs, right? Input, output pairs. And we pass it to this as object here. And now we're supposed to have something here in the train data set. But what's in that train data set? Right? What's encapsulated there? So let's try to print that out and see what happens. So let's try to print data set. What you would expect to see is the tensor again, right? The tensor, the input, the target, and the size. But what you get is something like this: is an object. All of that is contained already, self-contained. So let's see what's in this object. So we have different functions in that object. Let's see. How about batch size? Sorry. Right, so we have that. Whoa. Yeah, I never got this open before.
Seems like you're trying to print too much.
Yeah, it's too much. Yeah, so that's the reason why I never had it there in the first place, right? But so let's just continue. So we have all that information encoded already, and I would like to print something out, right? So what I do is I want to establish those batches. So what I do is use this other class here, data loader, and say, okay, I want to establish batch sizes of this size, which is 64. I specify that, and I want to drop the last. Sometimes you have batches that are not the same size, usually the remainder, so you have 64, maybe you have 63 in the last batch. We don't want that, we want to discard that, so we say drop last equal true. Then we want to shuffle again, okay? That's very important. So now we have, again, train data set. So let's just try again. So the validation data set, so the batch size is 64. Now everything is encoded here, and I can even print it out. Let's see. Let's see how I would print that out. So I have all these different functions. Let's see, data set. So you see an object, right? If I try to print the data, do you think it will crash?
There's only 64 records, right?
Great. So now when I try to print it out, it prints, right? So you can see that all the different steps, what you're doing is just have that very efficient way of encoding your data and making sure that you have it in the right dimension and sizes that you want. Okay? So you have access to all the different methods from that class. Yeah, it's a whole, yeah. Because I never specified, I never specified the batch. But I can do that as well. Let me just, I don't want to print that out. Right. So again, let's double check that the number of emotions is 6, right? That's the number of classes. Again, I have some utility functions here just to convert to pickles because I work with pickles. I prefer to do that. And that's the end of the tutorial. So what I did here was just encode the data, having a batch. Now this is just ready to be used, right? Ready to be used, train a model with it. That's your input, right? That's what we did. And that's why I labeled this as NLP basis, because you're not doing really NLP. All you're doing is just a lot of preprocessing and encoding. But that's a very important part of the whole framework, right? So I just stored my data here. And this should store into Google Drive, right? If you run those lines of code, that will store into your Google Drive. To have training, validation, and testing data set. So any questions before we go to a break? I think we have a break. We have 10 minutes more. There are some exercises here, I believe. Did I have some exercises? I think I did have one. So maybe just you can go back and review it. If you have any question, just try to do this exercise here. Just to review the code and understand, the different steps that I took to reach the last step. But this one is just for doing the encoding itself. Getting the vocabulary and indexing it and have that input tensor in the format that I showed. So just try to do that, and I think you can just reuse the code at the top here to get that answer. So just try it. If you get that, I think you should be okay. And if you have any questions, just ask. So I think it's just 10 minutes to the break. Yeah.
So here the tensor that you have is just going to be basically the index into your kind of vocabulary set of each word, right? I mean, you're not dealing with anything like a word embedding.
No, not yet. Not yet. That would be the other step. Yeah. Testing. I guess we can start. We'll try to wrap up with our notebooks here. Just to clarify, because I noticed like a lot of you had this problem with Google Drive. So sometimes what you need to do is, because you're using MyShare, you have access to, but you may not be able to. In the last step, you have this problem where you don't have permission to write into MyShare folder, because I didn't really grant that permission. What I would suggest you to do is just create another folder on your Google Drive, and then you can just store those pickle files to your folder, and then access them. You need to change the code later on, right? So just be aware of the permissions of that folder. Okay, so let's move on to part 4. Okay, so here we're gonna do the deep learning that I've been talking about a lot. So we already did the basics, which is the preprocessing. Here what we're gonna do is we're gonna build a model, train a model, construct a model, train it, and we're gonna use this RNN. That's very popular deep learning model that's commonly used for NLP tasks. And you will see that we can use RNN, LSTMs, GRUs. You can use any of those models. You can see how easily, later on, you can see how easy you can use those. So the first thing we want to do is load the data set. In the previous notebook, we had all the data sets stored, right, in the proper format. So what we do now is load it again. So you can see that each notebook is just like continuation of the previous one, right? So now we load it again, the same. So let me just try to do something here. Because at some point, because I don't have access, well, Google Colab only gives you access to 11 gigabytes, right, of RAM. So at some point, because I'm working on 50,000 records, at some point it's gonna break because I'm using one machine. So what I would do here is I would just close this runtime. I would just interrupt it. And you will need to do the same as well, because you're running multiple notebooks on the same data set. You can imagine it's using a lot of memory already. So it's good to always, I'll just reset runtime. Okay, so load the data, let's see. Right, it's the same steps. I have to mount my Google Drive all over again, right? Because I deleted the session from before, so. And that's how you will give it permission. I didn't show the step, but now you can see it. Right, and then you would enter that code again. Okay, so it's mounted. And then again, I would use the same class all over again to load the data set. This is just redundant because again, I just want to make sure that we are just doing the steps right. Yeah, so the core part of this tutorial is the implementation of the model. So we're going to build this model here. Let's see if I can get that on the screen. Now let's explain that. Right, so that's what we're going to build. So we have an input. We have the input, which is X. And then we have a layer here. We're going to use the GRU unit for that layer. And just a variation of RNN, a very efficient variation at that. And then we have a fully connected layer at the top, and then we have a Softmax to do the classification. So that's very standard things that we do in classification, a very standard model. And so now I'm going to jump into the implementation, the actual implementation of it. So here we have some code. Yeah, it's pretty small over there. Okay, so we have a model that we want to build here, and we have named it EMO-GRU, which EMO stands for emotion, and GRU is the type of RNN that we're using here. So we have an init function here, and notice there's like a super, right, the super class here. What we're doing here is we want to inherit from this module, which means we have access to all the different classes. We inherit all the different methods, right, from in this class, this module. So the first thing we want to do is establish what goes into the init layer. The init method. The init method is basically where you specify the parameters of the model, which is like the batch size, the hidden units, the number of hidden units, the embedding dimension. And now we're going to use embeddings, the vocabulary size, the output size, all of those different types of information that we need for the model. And that's where you would put that information. And also for the layers, we're going to specify what kind of layers we're going to use. So here we're going to use an embedding layer, and I'll explain more in details what that means. We're going to use a dropout layer. It's really good for regularization, which is allowing our model to more efficiently train. And then we have a GRU layer, and then we have a linear layer at the end here. So you can see it's like a chain of different operations going on here. So a lot of things are hidden here, but the most important thing to find out, to know here is that you can see that it's just a chain, right, of operations. And that's how you would build your deep learning model here. And another important part of when you're using RNN is that you need to initialize like the beginning of the training. So what you do is like a hidden state. It's called a hidden state. And what you do is initialize those to 0. So it's not so important like what goes here. We just want to initialize those to zeros. But there's a tutorial, like I would strongly recommend. There's a PyTorch tutorial where you can go and read more about what this function is doing. And this is the forward. This is where the input enters the neural network. So here we have, first we want to embed the inputs, which means that we're going to get embeddings from that inputs. And then we have like a hidden state that we're initializing. And then we have the GRU layer here, right? And then we have some outputs. After the transformation, we have some output. And then we have a extra dropout layer that we added. And then we have the fully connected layer. So when you look at it, it's basically this, right? That's what we're building here. The only thing that was missing here is the softmax. We didn't specify the softmax here. So typically it's like a common practice to have the softmax being executed later on, like in a separate function. So I'll show later where that is. So that's basically your model here. That's your basic GRU model, and it only takes a couple lines of code. I actually have extra lines of code that I don't really need here. I could have just made it into one line. So it's pretty simple. And that's why I said at the beginning that the chaining was the most important part, because you basically add more dropout maybe, or add another fully connected layer, or whatever you want to add here. Yes?
So if you scroll up to the picture of the model, right?
Yep.
You have 4 GRU blocks, right?
Yes.
So I guess kind of one question is, there's a solid line and then there's a dashed line,
Mm-hmm.
right? What's the difference between them? And also, what's the difference between, like x0, x1,
Yeah.
x66,
Mhm.
and x67?
Okay. So the x67 means it's just the size of the input.
It's 67
yeah.
units, or?
Yeah, 67 is the size of the input. So imagine the tensor that I showed with the numerical values, with all the padding and everything. So the max size was 68. That's why we have from 0 to 67, right? That's what the figure explains. Although the figure is like pretty high level, so you won't get that information from here. And I'm glad you asked, because yeah, that's just to clarify. And then the GRU, of course, is just like the whatever you want to make that layer, whatever size. Here I only have like each input going into each, unit. Because at the end of the day, when you're doing an RNN, you would have to do it for each input. You would have to have like a unit, all the transformation have to happen for each, right, for each component of the input. And that's just how the RNN is designed. But if you were using something like a standard neural network, then the unit size doesn't have to be of that same size. It should not be consistent like that. It could be different size.
So when defining the model in the code, should you, like, it seems like you would have GRU, it's only listed once rather than multiple times, whereas in the diagram.
Right. Right. So here, like, you saw that, so let me just explain a little bit more on that. So we have this, right, which is a GRU. You notice that the GRU, the first dimension is the embedding dimension, which should be the input, right? So, and then the other one is the hidden units, the number of hidden units. So these two are separate things, right? So the hidden units can be any size you wish, right? Just like a fully connected layer can be any size, like what we said. But the embedding dimension is very important that it's very consistent and it represents like the input dimension. Is that clear?
Yeah.
Okay. I mean, I think the documentation does a pretty good job of explaining it very well. And that's why I always recommend that if you really want to know more of what it's doing, because this is just very high level. If you want to know more, I really recommend that you look at it. Mm-hmm. Right, so then we have, let's just try to run the block of code. And one of the things that I really like to do when building a model is pre-testing. It's something I call pre-testing. So what you usually do after you implement your model is just go straight into training. That's the typical thing that you would do. But what I want to know is exactly what's going on, what each transformation is doing. I'm very curious what's going on, right? So I like to pre-test the model. So what I do is just generate some code. Let's see, just delete that. Right? So these are just like the parameters of the model, like the batch size, the embedding dimension, the number of units for the layers.
Sorry.
Yeah.
The embedding dimension. Didn't you just say that it's 68 or so? Because that's the maximum length of features?
No, so one thing I didn't explain. So we have the inputs, and the max length of the input is 67. But after that, after we have that input, then we have to generate embeddings, right? So embedding, that's why we call it, it's like a layer. So here we're going to generate embeddings for each one of those tokens. So now we don't have that max length, which is going to be the 67. Now the max length is going to be 256. That's going to be like the vector for each word, right? So all of that, you can see that it's hidden here. It's not really like, it's not explicit. You can see that it's just a line of code that's doing all of that. From how we went from the tensors with just the numerical values into the embeddings, and it's just line one of code that takes care of that. So we're taking like you have a vocabulary, and you want to embed like in a space all these words, and you want to have these words to have some kind of relationship with each other, some kind of what we call like a semantic relationship. So what's the relationship between king and queen, right? So in an embedding space, these words would probably be closer to each other. And so in order for us to do that, we need to encode these words. We have to have some kind of encoding, right? And that encoding is basically like latent, what we call latent features. It's just features that the model just chooses automatically, because it's a deep learning model anyways. So it chooses some latent features, which basically explains the semantic relationship between words in that space. So we have the king and queen, having some kind of relationship. And so you have that the distance between king and queen will be much closer to what it is to maybe say something like dog. It will have a further relationship. So that's basically the concept of embedding. I mean, there's a lot more information about embeddings that I'm not sharing here. But the point is that we need to have an efficient way of encoding that input. We're not going to use just the basic indices. We can use those features as just the basic indices, but we want to use something more efficient, right? So that's why we use word embeddings. So yeah, and I mean, I didn't mention at the beginning that I'm really not going to go into like the theory of all of the different, options and design choices that I use here. The whole point is that you can get an idea of how to use all the building blocks that PyTorch offers to get the NLP task done. That's the idea. So sometimes it may feel like I'm going a little bit fast, but I'm just trying to share some of my experience and the kind of things that I do building NLP models. So after that, we have everything. We have the model, and now we want to do. We have the batches, right? I spoke about the batches earlier on. We have all the different batches that we're going to feed the model. And we have this function here. Now, this function, I don't really use it here, but this is a very useful function for in case. I remember earlier on I said that sometimes I would want like the batches to be of the same size. So for some tasks that works, right? So I would want them to be of the same size. So this function takes care of making sure that some of those batches, are consistent, like the size is consistent. So that very simple function does that. And also what it does, it transforms the dimensions of the batches. But we won't use it here. This code is more useful for when I'm doing something like machine translation. But when I was preparing this tutorial, I just kind of borrowed some code from there, and I just adapted to the classification test. So I showed it here. Maybe it could be useful if you want to ever try that. So I'm not really going to explain exactly what it does, and I'm not going to use it. So yeah, I did have some example on what it does. So I have code for it here. So now let's explain like the details of this block here. So we have a device. Now the first thing you want to do before training is what kind of device you want to use. You want to use the CPU. If you have only access to that, then you use that. But if you have access to GPU, then you would want to use that. So typically what we do is we have this, we choose the selected device that we're going to use. And then we have the model. Now we create an instance of the model here. Remember, the emoji represents this one, right? And we're specifying all the different parameters that we need here. And those parameters are specified here. Right? The target size, the batch size, the number of units, the embedding dimension, and the vocabulary also. All this information that we collected already previously. And then we say, okay, we want to put that model into the device that's available. In this case, we have access to GPU because the Google guys are very generous. So they provide GPU for us. Why not use it? So we use it. Then we have we have a sample here. I just generate a sample. So notice that there is an iterator here. An iterator, which means that I want to just select an example of the training data set. So that means I want to collect one batch at least. And we want to check what that batch has. So now we have that batch, and I'm going to sort that batch. I have that batch here and I sort it. And so now, let's see. So the size of it is this, which is the 69 again. Again, it's 69, not consistent, right? Because I said 68, no, it's 69, but 69 because we added a padding, which is the 0, right? So we have that extra element that we didn't talk about much, right? So that's the size of the batch. So it's 69 by 64. Notice the dimension, right? So it's not batch size first, it's max length first, right? So that's key when you're going to train because we want to make sure that those dimensions are in the right places. So that's why I say it's good to always do the pre-testing, like what I call pre-testing, because just making sure that before we train the model that we have everything in the proper dimensions and the proper sizes. So, and then here we set up a training. Again, notice I'm creating another instance again. I'm just repeating the instance again, because again, this is separate, pre-testing is separate from the training. Now we're going to do the training. And we have two things here, which is the cross entropy loss, which is basically just computing what the loss of the model is after a couple of iterations of training. Now, the details of it are not so important. You can read about what each loss, because there's so many different losses that you can use. Just go ahead and read up on the tutorial, on the documentation, and see what each one represents, but we need a loss. We need to compute that loss because we need to know if the model is optimizing well. And then we have an optimizer. An optimizer is just like what takes care of the training, the backpropagation part. Again, you have options, a lot of options on what kind of optimizers you want to use. There's several of them. And then these utility functions, loss function and accuracy, is just to again, the loss function is just to check what the loss is. The accuracy is just to check the accuracy of the model. These are two separate values that we want to collect after training, after each round of training. So we have the training. We have the training now here finally, and you see it's okay. There is a lot of code here. So the most important thing is that we want to do accuracy. We want to collect loss, right? Those are the two things we want to keep track of. So we're going to run this for 10 epochs, which means 10 iterations. So we do that. So notice the for loop here. So it's going to be 10 iterations. And then we have the training finally. So here we have the training dataset instance here, right? And now we can just iterate over each batch and start to do the training. Now, before, what you used to do with this one is you have to do all the prepare the batches here in this code. So it's pretty messy that you have to do all the batches here, and then this code can get pretty long if you are doing all that code here. So why I was saying that the dataset classes and the data loader makes it so easy, because now I'm just using that train dataset iterator, and I'm just getting the batches that I need to train. Right, so there's more code here, and then we have the model, of course. Then we're passing in the input, passing in the length, and the kind of device we want to use. If we want to use a GPU or a CPU, but in this case, we want to use a GPU for faster training. And then we're just collecting loss, computing the loss properly here. And then we have this code here that we say, okay, now it's time. We have done the forward. Now we want to do the backward part. We specify what the optimizer is here. The backward part, right? And we want to do this step. So this is just pretty standard code that you use when you're training models with PyTorch. So this is not something that I made up. It's just very common. If you go to the tutorial, you will see that these 3 lines of code are always there, right? You always need them, yeah.
Since they're always there, since that's like 30 lines of boilerplate code, have the convenience functions in Forge do that for you, or do you have to write the same 3 lines every single time?
I guess that's a great question. I guess.
Errors, for example, you get that in a single line.
Yeah, I think that would be something that they would want to work on, because, yeah, it's just something that you need to put in there. Yeah, very standard. Yeah. And if you're missing one of these, you'll probably not get the training done. So, very important. So we have accuracy as well. We collected loss. We have accuracy as well. Not very important to know all the details, but you'll have time to go over it. And then we have, yeah, we want to have some, we don't want to do it for every iteration, but we want to every 100 batches, we want to know, keep track of the loss and the accuracy. And notice that here I'm using some special functionality here. So the batch loss, I need to put it into the CPU. It's more efficient to do that because it's just a number. Why would I want to do this, put this into a GPU? So you can see that I put it in the CPU, and then I detach it, and then I just convert it into NumPy, and it's just a value. So I have the flexibility to do whatever I want doing training with my data. Then we have validation, the same code. It's almost the same code that you use. The only part is that you would see this missing, right? Because we are just checking what's the accuracy of the model. We are not going to do training again. We're not going to do a backward again. We cannot do that in validation, because that's just typical things in deep learning. Right? So I have it already. I don't want to run it because I'm just suspicious that it will break. So I have trained it already. So you can see here that the training accuracy is 93 and the validation accuracy is 92. That's pretty good, I guess. For this kind of task, I mean, this is a multi-class classification. This is not a binary, so it's pretty complicated task, I would say, in my opinion. But you can see that a very, very simple model like a GRU with, dropout, a fully connected layer, and a softmax layer can achieve this accuracy on that very complex data set. It could show you that the power of deep learning here for NLP. And you can see that after each epoch, you can see that it stays relatively the same, right? And at some point, it will overfit. At some point, overfitting means that there is some like huge difference between the validation and training accuracy. So you see that, right? And then you will need to stop it. But I just have 10 iterations here, and you notice that we have a very high accuracy. At some point, you want to stop it. And there are methods that you can use, like early stopping. I'm not going to go into that details. I have another notebook that talks about this, so I will share that with you later on. And the other thing that we want to do after we have trained the model, we want to store it, right? Sometimes we want to do some inferencing on the model, and so we store it. So there's a very convenient function that we can use. PyTorch offers this one. So it's just like torch.save, and we have the model, and now everything is saved and serialized properly, right? So the model name is just MOGRU here. And now if I want to use that or share it with someone, I can just use that, and then that person would just need to load the model, basically, and do inferencing on it. That's basically what would happen, right? So that's the end of the notebook itself. And the other part is how to load this model and how to properly evaluate it. That's kind of the last segment of the tutorial. I think, let's see how much time do we have. So the end of the tutorial is 4:20, right? 4:20. Okay, so we have roughly...
It might be 4:40.
4:40? Okay. Okay. So I do have like a special like group exercise that I really want us to work on, and just to put everything together that we have discussed today and that we have learned today. So one of the things that I really wanted to try with this model, because I showed a very simple model, right? A GRU, you saw in the figure, it's very simple. But you can do like extreme deep learning, like you can do many layers of GRUs, you can use LSTMs, you can use all the different components that are offered by PyTorch. So what I would like is that we can just join, like make some groups, like I would say large groups, because maybe I'm thinking something like 7 or 8 groups, and then I would like that you guys can come and present your model. And what I would suggest you to do is use the same model that we have here, the same model that I showed here, and look, I can just show you how easy it is. Let me show you. So we have the model here, right? All we need to do is just go back to this function here, and then you can add whatever you want to add. So you can add another fully connected layer if you want. You can do that. You can just copy, paste, then you can just continue building on top of that. So I would really like that if we can get into some groups and try to go into the documentation, like just read up on it a bit more, and just have that practice that you can go read up more on the documentation and try to, and you can add more GRUs if you want. You can change it to LSTM if you want. The documentation will tell you exactly what you need to change when you're using different components. So I would really like you guys to try it out. Just change it, try. Don't be afraid to change the code, because you will have access to the original code here. And then see if you can improve that accuracy. Right, this is 97. Maybe you can improve it. I believe you can improve it. And all you need to do is just change that model that I showed. So do you want to try it out? I think that would be nice. And I would just want you guys to just share what you learned. Just share whatever you learned so far, and just try it out. Can we do just groups? I mean, I'm thinking like 7 groups or 8 groups, and we can just share, what we have made. Okay. Sure. So do you prefer that? Do you prefer we move on to the other? Yeah. Okay, perfect. Because I have the other one, so. Mm-hmm. Yeah, so I would definitely have to change forward and then add it here. Yeah. So here I would say FC2. Yeah. Mhm. Yeah. Okay, so we can just do port 5, I guess.
The initialize hidden state function on that model,
Hmm.
like that's something that's overridden from the base class, right? Like you didn't implement that yourself, right?
No, yeah, I just use the standard thing that's using RNNs. Yeah. Okay, let's jump into part 5. And part 5 is like why I had it like hidden here, optional, is because it's more like what you would do when you're doing research. It's very important. Okay, so you have an accuracy, but you don't really know why you got that accuracy right. How do you explain why that accuracy is so high? So something you want to do is like properly evaluate them all, and that's just the part 5. So I'll go over it. Definitely want to share that as well. Let's see. Okay. So all right. So part 5, evaluating NLP models. So I stored the model the last time, right? And then now, again, I'm just doing the necessary steps to make sure that um, I'm loading them all. Notice that one of the things that a lot of like these programmers are working on these tools is just trying to make sure that we have tools that you can properly use for like sharing models. Like, okay, we have a model that I train and I want to share with someone, and I want that person to just load that model and quickly use it. That's something that I would love. I think when we're working in teams, that's something that would be perfect. But it's so hard to get these things right when you're building these deep learning frameworks. So one of the things that PyTorch offers is just, okay, you have all the model, but you still need to do some extra work in order for you to use that model for inferencing or evaluating later on. So you'll notice here that I'm using, so I loaded, so here I have I have to declare again what the class is and everything included in the class. Notice that there's no code before that. It's just the same code that I use to specify the model. I just basically copy and paste it here. And then I have this special line here, this important line here. Let me just try to make this a little. Right, we have this line here where you load the model, right? So now you have the model stored again and you can now use to do inferencing. Yeah.
So when you load someone else's model, you have to know exactly how to do it.
Yes, that's kind of like a drawback. Yeah, that's kind of the drawback. There's so many reasons why it's designed that way. So many reasons.
I'm sorry, what do you have to know if you load someone else's model?
So you'd have to know like the properties of the model, like you could see embedding layer.
So your whole chain, basically, you have to know
Yeah.
everything you apply to the chain.
Yes. Yeah. There are other ways you can store the model and load it. I just find that this is, for me, the easiest way to get things just running fast and easy. But there are other ways that PyTorch offers for you to store and load the model. There are other practices that you can use. This is just one way you can do. All right, so let's see. Right, so I have that model here. And now I want to evaluate the model, right? What do I mean by that? So I want to know like why this model does so well. Like it has a high accuracy for a multi-class problem. Why does it do so well? So one way you can do that is do some inferencing on it. So I have a validation data set, like a held out data set that I can use to test the model. And one of the things that I'm looking forward to do is, so you can see again, this is standard code again, all over again. I'm just repeating the code here. That's something I do when I'm doing experimenting a lot. I like just to redo things, just making sure everything is right. So you don't have to do all of this code repeated again. You can just use one notebook and do everything in one notebook. Okay, so here again, so now we have noticed that I want to do, like I want to inference on a set, like a part of an entire validation data set, right? Sorry, the test data set, right? So what I do is I don't need to do training. I don't need to do like, okay, epochs and other stuff because I just want to do one shot. I want to just check the accuracy of the model that one shot, as this is inferencing part. And one key thing is, notice I have the model running on Cuda, on the GPU, right? But do I really need it for it to be in Cuda or a GPU when I'm doing testing? That's something that you may want to ask yourself, right? So in this case, I would just use, because I have access to it. But if you are paying cloud services and you don't have that amount, that amount of money to do that, you just want to make sure, because initially this model was trained on a GPU, so you want to make sure that you change it to CPU, like that, right? And you do inferencing on, and this is very useful if you are sharing models with someone, right? In this case, just leave it as that. Okay, so I didn't run accuracy. Missed out running some of these. Other stuff I'm not explaining again because it's just repeated code. Okay, yeah, at some point it told me that I need to get rid of all the, because I'm just overusing the stuff, right? So I just need to do it all over again. Okay. Okay, here we go. Evaluating. Oh, wow. Testing accuracy. I may have done something wrong. You got the same value? Yeah, yeah. I may have overwritten the model itself and the weights, so you would see that it would change. But yeah, if you do it right, if you do all the notebooks right and you run them, in that sequence, you'll get a high test accuracy for sure. And one of the things that I wanted to show is, it probably won't work so well here, but so I have a lot of code here that I show that I typically use when I want to evaluate like a classifier. So just a lot of code. And basically what I want to do is just plot a confusion matrix. So a confusion matrix looks something like this. So you can see that model didn't do so well, right? But generally what you want is that you want all these values to be super high, and then you know that your model does well. Yeah. So you can see that the accuracy is not so good. Not so good because I did something wrong with when I executed those notebooks. I did something wrong. So the model wasn't stored properly. I used a different model probably, and I stopped training maybe at some point, and it didn't do so. It's probably not a really good model here. But yeah, you wouldn't get a high accuracy if you did right, if you run all the notebooks right, and yeah. So you have access to all that code here. All that code that you can generate the prediction and you can do the inferencing and everything. And it's just a good way when you're doing research in NLP just to properly evaluate your models. You just don't want to focus too much on the accuracy or the loss, but you want to properly evaluate it, especially for a multi-class problem. That's really important. Yeah.
Can you scroll back up to your confusion matrix?
Oh, okay. Here.
Hard to see here, but so if you have a better one, and you can see that some things are doing well, but some things are doing badly. So you find one that's doing badly. What do you do next?
Yeah, so what I would do is, like for this kind of problem, it's a good question. For this kind of problem, what I would do is, I know, for example, like in my case, it was like I had like love and joy, like, there's some overlap, right, in the language used for joy and love, right? That's very common. So something I would do, and I think someone brought it up already, I would definitely want to do a lot more preprocessing. I would definitely want to try to see if or even obtain more data. For deep learning cases, I think it's really good to have a bigger data set, just to make sure that the model has enough data to properly learn those features and weights. that's one way when you're using deep learning. But when you're using like the classical way of machine learning, then you're engineering features, and I really like that because you can use some domain knowledge. For example, like I know love and joy will have a lot of language overlapping, so I would probably want to inject more of the language that's going to distinguish those two classes, right? So what I mean by that is get more instances, for example, in this case. Definitely would be more clear if I had like all the steps that I did for collecting this specific data set. Because here I'm just showing like, okay, this is a clean data set, but I actually cleaned the data set and reprocessed it already with many different steps. And as I said earlier, I have that notebook that I want to share because I think it has a lot of like information that can help you answer that question. But for every case, you need that domain knowledge. So yeah, there are many ways you can do that. Yeah. But since now we're only focusing on deep learning, you notice, I guess a bigger data set would be able to help with the classification accuracy. Mm-hmm.
So it didn't, I don't think I understand the deep learning space all that well, but it didn't do things like remove stop words, lematize, fancy tokenization.
Yeah.
Any comment on that?
Yeah. So for this kind of task, I didn't have to do a lot of that. If you notice, right, because the data was super clean. I mean, if you analyze the data more in depth, you would see that the data has like remove stop words, right? It has like emojis remove. I think emojis are removed as well. Emoticons were kept. Some emoticons were kept, but I just kind of specified what I want to keep and what I want to move to filter. Yeah, yeah. I already did all of that already with the data. That's why it's so clean. But you would have to do all of that yourself. And it would change for every data, every use case. It would be different, I guess.
How did you send the labels?
Yeah. So the labels were like, so it's a Twitter data set, and each label has, yeah, it's a very important. So it's connected to your question as well, because for my case, I just had to collect like a series of hashtags. Like for example, like surprise, I would have like hashtag surprise or hashtag wow, and I would use that as a weak label, like a noisy label, to basically determine the class of the record. Yeah.
So the diffusion matrix we want to see is the I matrix?
Yeah, you definitely want to see that diagonal, that I, that I showed. But yeah, we don't have we don't have the time, I guess. I guess we can try to fix it. So let me just try to rerun this notebook, and while it loads, maybe I can answer more questions and see if it works. Yeah.
So on the data collection side, I don't know how many training instances you have, but you said the more you have, the better, right?
Mhm.
What if you don't have a lot? Like you have something that you want to do, but maybe you don't have any labels. What are some strategies or techniques to go about building a data set?
A data set. Yeah. I would definitely. There are some techniques like in NLP. Data augmentation is one of them. It's not so clear. Like I've been following this research space a lot. It's not so clear how you can generate like text, right? Keep generating text. So like for computer vision, it would be much easier. Yeah, like shift the CAD. Yeah, definitely. So that's something that's not so clear in NLP how you would go about doing that, because everything is discrete. So yeah, so that's the kind of challenge. But I've heard some people working on using like embeddings to do that. I think embeddings is the key thing to properly be able to like auto generate text, like synthetic text. So basically, yeah. But for my case, why I didn't focus on that is because I have that domain expertise which I can use to collect larger data sets. But it's a lot of tedious work, right? In my case, I had to do like more hashtags, find out from people manually what people are texting or what people are tweeting, and if that is related to emotions, and I have to do some evaluation, and I have to use like Amazon Turk to ask people if those hashtags are really what they are, and so I have to get a lot of like that domain expertise and evaluation from others. So it takes a lot of work, but yeah, there's no clear way how you can go about generating large data sets.
How do you know if you have enough data? Like,
Mm-hmm.
when do you stop? 1,000 instances, 10,000? Like, I mean,
When do you stop? Hmm, I guess it depends on every task. I guess this is not a very simple question to answer. Um, I guess for me, it's like, okay, I tried with a sample. By the way, I didn't try the entire data set, right? And you can see how good the classification is. Um, I guess that's an indicator that I can stop because we have a high accuracy, we have a low loss. That's a good indicator. But what do you do in cases where you don't have such a clean data set, you don't have good accuracy? That's your question, right? What would you do in that case?
yeah, like, I mean, when you say, like, hey, I'm good, right? I mean, you can always get more, right?
Yeah.
But if you're starting with a small amount, at some point, you need to say, hey, this is good enough.
Yeah. I guess, yeah, like I say, it's properly evaluating it. I guess doing the confusion matrix for me help. That's the indicator for me. If I do have something, so again, it's like you need some kind of like domain knowledge at the end of the day. Like that's my opinion. You need some domain knowledge because if you're gonna do something in computer vision, you have to explain why that model is doing so good. You have to be able to explain that, right? I mean, if you can apply it if you like, and a lot of people can do that, but if you really want to go to the extreme and be innovative, you would have to just learn exactly, what the machine learning model is doing. So,
So on the vision side, right? I mean, some people might do some kind of segmentation, right? Like
right.
You can plot out a kind of heat map of saying these
Right.
are the features that they're using to recognize that this is a cat or this is
Right.
a dog or something, right? Heat map that shows you the elephant in the
Yeah.
room
Yeah.
in the picture. Like, is there any kind of heat mapping applied with like NLP? Like, these are the features or these are the words that it's using to recognize joy or sadness or something?
Yeah, we do. Let's see. Let me try to show you like a notebook here. So this notebook here that I have, this extra notebook here, is basically text summarization. So it's just another NLP task. And what I do in this notebook uses the same code, by the way. It's just a model time is just different. So it's a lot of code. Let's see. So I have this really wonderful like visualization that I can use, right? In this case, is basically visualizing the same thing you're talking about here. Here you can see that. So this is like an attention, weights. Those are attention weights, or we call it attention weights, and it's basically indicating to you what parts the model is looking at, right? That are important during training. So in this case, you see that here it's focusing a lot on bush urges. So those words are important for this summary, and so here you see original summary, and then the predicted summary is this, right? So what the model used to make that proper prediction, so that's what it means here. Yeah, I mean, there's a lot of information that I can share here, but I guess just to answer your question, there are techniques. They're not fully developed, I guess, in my opinion. You can use them to get an idea of what the model is doing, like interpret what the model is learning, what areas are important. Like in computer vision, I guess it's easier to do that, but in NLP, we're still struggling with that area. So, yeah. Yeah, I will share all of it. I have like a series of notebooks. I may have up to like 20 notebooks that I worked on. And the good thing is all of them are consistent, use similar code, so it'd be very easy to understand, I guess. Just the data set changes.
Yeah, because I think it's super important to be able to explain the model and to show people which words are the trigger words for any given outcome.
Right.
Because like unless you can do that, you probably want to use simpler approaches that are more scalable.
Right. And I have another one here for neural machine translation. And this one uses the attention mechanism again. And it's the same code, the same functionalities, just a different data set. I will also share with this if you're really interested in it. Yeah, I will share this. I mean, it takes a lot of time to explain all of this stuff, but I think these notebooks were pretty helpful for a lot of students. I shared them over the past. I really got a lot of good feedback from because I spent a lot of time trying to explain, write a paragraph about it and try to explain it in a very intuitive way. Because these things are very complicated, but it's important, like I say, to always start from the beginning and just go step by step. Just don't rush into just building that model. So let's see if I can get that model running and see if I can get that accuracy. Let's see. I think I think it ran, so let's just try. So I might have to. Let's see. If you have any other questions you want to ask, or maybe after the session, feel free to approach me and ask me. I'll be really glad to answer your questions. Wonderful, got it to work. Okay, so yeah, so I guess that was a very important question, the one you asked, because I was going to speak about that here when I was showing the confusion matrix. So you see here for joy and love, there is some overlap there in the language used. So you can see that the model is confusing those labels here. So that's the true label and the predicted label. And for surprise, usually it doesn't do so well. And one of the reasons is that there's a lack of examples for surprise. And let's go back to see the distribution. So for surprise, you will see that it's 78, and for love, it's 84. So let's go back and see what the distribution of the data set was. So you see surprise is like the class, like with the lowest examples, right? It's so small, it's like maybe less than 10,000 records compared to all the rest. And love also is the second, this class. So you can see that at training time, it will affect them all at some point. It's something that I try to argue when I wrote my thesis. I try to argue this a lot, and I try to run a lot of experimentation to make sure that what I'm claiming is right, because there may be other things that I'm not considering. But yeah, this stuff that I'm sharing here is just part of my PhD thesis. So this stuff that I properly evaluated. Yeah.
So when you're training the model, right, surprise is very low relative to some of the others, right?
Mm-hmm.
So do you truncate examples from the other, or do you add more, do you
Mm-hmm.
truncate the surprise examples? Like,
That's something you can try. You can definitely do that. For our methods, for sure, that help. Trying to balance all the data sets. But in that case, you would lose, right? You would lose some, like, if you really want to focus on some emotions, some people, what they do is just reduce the number of classes as well. So instead of having the surprise and love, maybe merge it into one or something like that. In this kind of task, you can do that. Yeah, there are many ways you can try to fix it. Yeah, many ways to fix. Mm-hmm. Sorry, a testing library. Yeah, another great question. I guess for most people that use PyTorch, that's the number one thing they would complain about. There are not a lot of good functionalities for testing. It's because PyTorch was actually built for research purposes at the beginning, and so most of the things you only have access to are just the fully connected layers, the RNN, and the other stuff you have to do it on your own, which is the evaluation part. So I have all that code that I have to implement myself to properly evaluate the model. And I think that's done intentionally. I mean, at some point you have to have the responsibility to actually evaluate the model yourself. So yeah, but there is some tool that they're working on. I think it's called PyTex, I believe. So it's a relatively new part of the ecosystem that they're trying to address these issues, like how to evaluate them all easily with PyTorch. You don't have to use an external library to do that. Yeah. So any more questions that I can answer for you? So the other part I really wanted to share were those three: machine translation, which is, I think, machine translation. If you're really interested in NLP, this is one area I would strongly suggest for you to explore. it is really challenging and interesting because the whole setup is so different from classification. There are a lot of techniques that you need to be aware of using, and some of these techniques, you can use them in the different types of NLP tasks. Like I said, most of the things that I share here are actually machine translation stuff that I just use, and I use it for classification. So it's a very interesting field. I guess you can learn a lot from it. So yeah, if you don't have any other questions, I guess it'd be good to stop it here. Yes. Okay. Thank you for reminding me. Let's see. Do I have one? Okay.
So we talked a little bit, like there are different models that you can use for this kind of neural network or deep learning. Can you maybe walk through the models and what the differences are, like LSTM versus
I didn't get your question. Sorry.
Can you walk through some of the different models and what the differences are for deep learning?
For which kind of models?
Like what's the difference between LSTM versus Jira, etc.?
Yeah. So there are definitely a lot of the things that I didn't really talk about here. You mean like GRU? So yeah. So GRU is just like a very simplified version of an RNN. And then LSTM is a lot more complicated. It does things more efficiently. It adds actually more components to the RNN, to the standard RNN. So it's just a lot of things that are changing in the model. And I didn't really focus on that here because, like I said, it wasn't like a deep learning course or tutorial. But yeah, those things are very important to know, especially if you want to use them here. But yeah, I would suggest if you're really interested in it and you want a good place to start, that documentation for PyTorch, I think is the number one thing I would recommend. I wouldn't even recommend books. I would just recommend go to a documentation because the documentation actually has like explanations. It has like references, like the proper references of what was used, what paper was used to implement that model, for example. And it has like a really, really nice explanation of what the model is about. Yeah.
So you did this classification problem for your dissertation.
Yeah.
How long did it take you from the moment you from conception through final evaluation of the model? Were you doing all
Yeah.
that?
So for me, it's like initially I started in machine learning, basic machine learning, like doing like I still enjoy that. I still enjoy like establishing my own features, because I have a lot of domain expertise in this space. So I just, try something like an SVM or try something like a naive Bayesian classifier. It does well. It actually does well for the task. And there was no need for me to do deep learning. But as you can see that one of the things that I showed here was that if you have a lot of data set, you can actually achieve it without having to do that tedious work, right? If you're all interested in accuracy and this kind of thing, you would get that kind of result. It took quite a bit of time. Most of my work was basically trying to combine like traditional methods with deep learning methods. So I have some papers on that. I managed to publish this year, past year, I mean. I discuss a lot about that, like what are some of the drawbacks, because I don't know if you're familiar, there are a lot of trending models like BERT and OpenAI, GPT, and all these new models that are coming out from these companies. I compare all these models with this kind of task that I showed here today, and I show the differences. And it's unbelievable that something like an OpenAI GPT, which was trained on a Wikipedia dataset, can actually outperform all the other models that I trained, even models that I trained on like data sets, like domain-based data set, like a Twitter data set. Even those models were outperformed by a GPT, OpenAI GPT, which is outstanding. It means that deep learning is actually working because you can see, right? But it raises questions as well because what is that model learning, like you said, right? Like you pointed out, what the model is learning. So that's an area that, we are working a lot in NLP, trying to understand. because I think that's a very important point, very important part of the work that we do. I try to explain it. Otherwise, we're just coding, and just combining GRUs and just doing that, but it's no fun if you don't understand it very well.
So wait, how long did it take? Like
Sorry.
the question was how long the time it took you. So were you working on this for several years?
No, I did it. So I did my thesis in like 3 years. Yeah, 3 years. I was very fortunate because, like I say, I was working in a task that not a lot of people are working on. I'm not sure if you have ever seen like emotion classification. Maybe you have heard about it, but not a lot of people are working in this space. Thank you. Yeah, so I was fortunate because of that. I mean, when I built my models, there wasn't a lot of papers to compare with, so it was good for me. I got lucky. But yeah, now if you want to get into this space and you want to do this kind of work, you will see how competitive it is because companies have a lot of GPU power and deep learning is working, so it's pretty tough. Yeah. Any other questions? Yeah. Oh, I'm not too sure of that. Maybe contact to me after. Definitely answer. Yeah, definitely. I would definitely would like to chat to you more about it. Yeah. Mhm. Let's check that again. Yeah, that's the one. It doesn't work. Well, they shared the wrong one. Maybe someone can help me double check. Double check, see if they're right. Wow. Sneaky small or. Yeah, so there was an R missing. Yeah, so one more thing that I wanted to share with you. Let me see. Just one more quick thing. Just quick advice is like, I would say, I always say this, I was fortunate, like I say, that I got to do a PhD in NLP and I get to teach like this. I'm very fortunate and I'm really happy and I really like the turnout of today. And I really appreciate you being here and trying to learn this stuff. One thing I would say is don't rush. There's plenty of time to learn. A lot of the exciting results that you see today are just stuff that, it's just like a lot of repetitive stuff that's going on. And companies have a lot of GPU power, so they're able to get those good results. But there's a lot of things you can work on and improve. And enroll in courses, but be sure to practice on your own. That's something that I try to highlight during this tutorial. Enroll in math courses, most people would tell you don't worry about the math, but you can see that PyTorch actually makes it super easy to go through the math, do the derivations, do the computations in that computation graph. I think that it's really helpful. Try to implement papers on your own. That's the way I started. I just went and I started with something like the word embedding paper, like a skip gram. I have like a notebook for that where I implemented myself. And like CBAO algorithm for word embeddings, I implemented that myself as well. There's a lot of like cool stuff in the PyTorch documentation, which you can use also as a really nice guide to know that you're going in the right direction. Because sometimes that's kind of like a challenge, right? Where to start? That's a big question. So I guess these documentations really help for that. There are many books. Theory is good to learn as well. It's also nice to combine these different learning resources. If you're only learning from videos, it's pretty difficult. For me, in my personal experience, it was difficult. I try to go to meetups a lot and talk with people and try to understand the use cases that they're working on. And I appreciate the questions that you ask about the data sets, and the kind of challenges, because all these things really, help me to understand the problem better. So I appreciate that. For me, future work is like, I want to extend these notebooks. Eventually, I want to make it like a book. So feel free to just keep up with me. I have a Twitter that I constantly use. I'm always trying to help students to learn this stuff from the beginning. So I'm always trying to adventure into a new task. For me, it's just exploring the area. Yeah, and there are other sophisticated techniques that I really didn't discuss here, like GANs, which someone raised earlier. Like, what do you use for doing like natural language generation? So you can use those generative models. So also a really interesting area as well. These are just some references. So these are just some books. I don't usually recommend books. That's not my thing. But I would say that these books really helped me in my learning. This is a recent one, NLP with PyTorch. That's the recent book. I haven't really read this book, but I heard it's good. I guess you can try that. And Deep Learning with Python from Chole. It's a really, really good book if you want to learn deep learning. I strongly recommend this book as a starting point. There are other really good books here for learning theory. This one is really great. Neural network methods for NLP. It would help to answer questions like what's the difference between LSTM, a GRU, which sometimes you want to know. That book will really help you and create a really solid foundation for your theory. Yeah, and there are some websites I share here. One more last thing I want to share before you go. So I partnered up with another researcher to create this really nice website here. And basically, it's the foundation of all the stuff that I'm doing here. I'm trying to teach things about NLP and using deep learning techniques. So this is if you ever want to know like where to start, we created this project. It's like an ebook where you can basically know where to start. So we start at word embeddings and character embeddings. Then we go to CNNs. Then we go to recurrent neural networks. Then we go to recursive neural network and all these models, right? It's a step-by-step learning the theory. Eventually, we plan to incorporate all these notebooks into this, so we have like a full-fledged learning resource that you can use, and you don't have to go all over the place to learn this stuff. So that's kind of the intention behind this project. Most of the things are taught, yeah. So it's in the, so it's here? Yeah, the last one. Yeah. So it's pretty useful for that. It has some of the equations I use here. Let's see. And it has like, what of the state of the art models used for what kind of task. It's a really intuitive like ebook. Definitely check it out if you're interested in this space. If you ever have questions, please email me. You have access to my email. You have my Twitter. Just feel free to have a discussion with me. I'm always free to ask. It's my job, educating, so I'm always free to and excited to always answer your questions. Thanks a lot.